of artificial intelligence, and we can create prediction or classification based on the on data that we set as input. We can, for instance, supply images with cats, with dogs, with humans, and then a machine learning model will understand or will predict with new image if there is a dog, a cat, or a human. We have two types of learning. One is supervised and second is non-supervised. Basically, if we provide the tags, what is happening in the image, we have labeled data. If we don't, this is non-supervised. I was saying that non-supervised would be, for instance, when we go to online shop such as Amazon and we get recommendations of products. In this case, these products are not randomly selected. A profile is created of us. Even if we have not registered in the website, there is information like from where we are connecting. And of course, if we sign in the website, then the store will know, okay, what is our maybe age or some range of age, what are our preferences, okay, if we like sports, if we like video games. And based on this data, it will be supplied to a machine learning model that already related some other customers, and we will fit in one profile and we will get recommendations from that profile, which means other customers which are similar to us, to our preferences. Okay, so this is one example of non-supervised and clustering. Okay, and just some question. You can see my screen again. I would like to know if you can see my screen, because there is a delay and I'm not sure, but I hope that you can see my screen. Then we have deep learning. Deep learning is part of machine learning, but in this case we are focused on artificial neural networks and many layers of neural networks. Basically here we discover patterns, and these algorithms are applied in several layers of hierarchy. The idea is that, again, we will try to predict, we will try to classify something. But these deep learning tasks really take huge amounts of information, and they are specialized in this based on the structure. And actually, we are going to talk briefly about this deep learning process. Okay, thank you. Good to know that everything, there is a delay, as I was saying. So, in this case, in deep learning, we take an image, for instance, and we will try to extract some features, low-level features, then we'll go to mid-level, high-level, and this will be supplied to a classifier in order to get an output. For instance, what is happening in this picture, or how we classify this picture as indoor or outdoor. How these low-level features are extracted? Well, first you can see, maybe we go to really low level byte per byte. We get some edges maybe. Then we go to upper level. Maybe we apply some convolution. We will talk about convolution. After that, we get something, maybe with color. Maybe we get some representation of this picture, what is happening in some specific parts of the picture, and we get a field theorized vector. And we will know, or if we find these patterns later, we will find out if it is an indoor or outdoor picture for new data. So this can be applied not only for images, where we go from pixel to edges to textures and then to discover an object. We can also apply it to text, for instance. We start with just single character. Character creates words. Words create sentences or word groups. Then there are clauses, yes, and everything is a story. So as you can see, we can go from low-level elements until greater ones, right? High-level features. So we know what is happening in this whole set of characters. Okay. So that's the idea. Each module in deep learning transforms the representation into higher level in a way similar to what human cortex does. And just general information, what is happening here. In this case, we apply a filter, which is basically a matrix. Yes, we perform mathematical operations to our input image. Yes, so we are actually modifying it. Then we take some section of this picture, we apply this filter, and we get, yes, based on this mathematical representation, yes, we get another or convolutional layer. Yes, we maybe get some black and white image or picture of the representation of it. Okay, so that's the idea. We have the original image, we apply a filter, maybe this filter applies black and white, and we get convoluted or modified image. Then this process is repeated several times. Yes. So this is just the same as we described in the previous slide, but in mathematical expression. Yes. So basically, we take sets of data or matrix of bytes, right? And we apply a mathematical function, yes, which is the filter that we mentioned earlier. Okay, and this is the convoluted image, right? Every value that we get. So this is how we obtain higher or complex features based on low level. Okay. As I said, this process is repeated several times. We maybe apply another different filter to this convoluted image. Then there is also another process in between convolutions, which is known as pooling. Basically, the pooling is taking a subset of the convoluted image, and we might apply either max or average pooling. Basically, we are going to create another image, but for instance, if we selected max pooling, we will choose maybe this square 2 by 2, and we select the maximum value. So you see 4. Then in this other part 5, and so on. So this output matrix represents this set of data. Okay, so this is part of the convolution that is performed in this operation. Okay, And as a whole, the convolutional neural network is basically we take the image, we apply convolutional layers, several convolutional layers. Okay, this is the size of the maybe 64, 128, and so on. I said this is really a lot of operations actually are happening. The idea is to, at the end, determine, okay, what is here? Here there is a living room, or there is a bedroom, there is a kitchen. What is the score that this picture gets for each of the categories? Okay, but it is quite common that in a convolutional neural network we have this process several times. This convolution and pooling repeated. Even the size can change. The size of the pooling, the size of the neural network. There are different deep learning techniques. This is one. There is regression, for instance, or recurrent neural networks. So yeah, there are several possibilities. Then we can go to ML.NET. ML.NET is an open source and cross-platform machine learning framework for .NET applications. It is quite easy to start because you don't need data science experience to begin with. And if you are a C# or F# developer, you can take your skills and knowledge in order to integrate in your .NET applications. And it is important to mention that this framework is open source, so we can collaborate, we can improve it. And it is also cross-platform. So the solution, the problem, sorry, the programs that we create can run on Windows, on Linux, on Mac, and we can also take it to the cloud. Basically, ML.NET is a NuGet package, which is Microsoft.ml, which is quite useful for most of the scenarios. But there are also other packages which are useful for different tasks, such as recommendations, image classification, if we want to use TensorFlow, Onyx models. We can also load information from a database with the system.data, SQL client, for instance, NuGet package, but this is not only SQL available. We can also use Oracle or MySQL or other providers. Important element in an ML.NET program is the ML context. Basically, this is the starting point. We will see an ML context in many applications, in many operations. This is the entry point for all our operations. We have the context, and then you see that we can apply a lot of information. We can train, we can predict, we can prepare our data. Okay. Then we can transform our data into a table. In this case, this is known as iDataView. This is how we send the data in ML.NET. Basically, you can think of it as a matrix in memory, as a table in memory, which can accept a lot of dimensions. It is efficient. It uses lazy loading. It means that maybe we have thousands of information in our data sets, but they will not be loaded immediately because maybe they are not required. But if we need 5 rows or 10 rows, they will be loaded, but not all thousand of information. Only what you need. So this is important. And it is also immutable. This doesn't change. This iDataView has a schema, or has it uses a class Actually, we see it here. Basically, we have our data. Maybe we have a CSV file or a table, and we basically create a class in C# or in F#, which represents the data. So we have maybe here 5 columns, and here we will have 5 properties. Maybe we have different names for the properties. That's okay, because we use an attribute load column to specify, okay, this property represents the first column. This property represents the second column, and so on. And a DataView schema will be created based on this in order to load an iDataView. So as you can see, the iDataView has the data that we have in our dataset in memory. Okay. Then we have iEstimator and iTransformer. Basically, the iEstimator is the plan that you want to execute at some point. It defines the operations that will be executed. Then the iTransformer performs these operations. So you can think that the estimator is a plan. Okay, maybe we want to normalize data. We want to replace missing values with the average or with the maximum value or minimum. We can map columns. We can convert from integer to classes, or we can apply some hash function. We can transform text. Yes, this is the plan. We create a pipeline with it. And after that, we execute the process. When we execute it, we obtain a transformer. We perform the transformations of our data. In order to transform this, we have to use an algorithm and perform a task. And these two elements create a trainer. What is an algorithm and what is a task? For instance, maybe we have a stochastic dual coordinated ascent or multi-class, not multi-class, maybe neural network or PCA, whatever. We have algorithms. Then we have a task. What we want to do? Maybe we want to classify between two between two classes, or multi-class classification, or maybe we can to apply prediction or regression. Okay, this is the task. Then we have a specific trainer for task and algorithm. Maybe we have SDCA non-calibrated binary trainer. If we have different tasks, such as multi-class, then we will have SDCA non-calibrated multi-class trainer, and so on. Okay, so we can combine tasks and trainers, and then, algorithms and tasks, and we will obtain trainers. That will create a model, and basically the model is the output. We want to say, the model is a zip file, serialized, which contains data schemas, data transformation, all the algorithms that were applied. And this is what we are going to obtain after we train our data. Okay, and this is what we are going to use in different types of applications, desktop, mobile, or also web. Just a second. Because I'm going to start the demo very soon, but my Visual Studio is not so okay. Okay, so what if we want to apply deep learning to some model in order to perform image classification? Okay, well, ML.NET provides several packages using, for instance, TensorFlow, ML.NET TensorFlow transformation. There is a C# binding. There are some libraries such as C# TensorFlow. Yes, and we can even apply something called transfer learning. So maybe we created a model using TensorFlow, which was based on ResNet or Inception, which are well-known algorithms. And these models were created using many high computational resources. Maybe we used thousands of classes to know if there is a dog, if there is a cat, if there are several objects in one picture. Maybe later we would like to create another image classification model, but this one is more general. Maybe we would like just to discover if in the picture there is a pet, okay? And what's the difference, or how we create this pet category, okay? We supply the model, the model that was created before for specific classes, and then we say, okay, we supply a picture of a dog, then a picture of a cat, a picture of, I don't know, a teddy bear, okay, and we say, okay, these are pets. Internally, the model will know, okay, yes, this is a cat, this is a dog, this is a teddy bear. But for the generalized model, it will know, or it will be classified as pet. Yes, so basically, we are creating another machine learning model on top of the other one. That's known as transfer learning. Okay? And then, as I said, I'm going to show a demo. Just a second. Because for some reason, my Visual Studio and also my AnyDesk crashed because I have it on the other computer. So please just give me a second. I will try to get back to you as soon as possible. Okay. Sorry about this. Since I am not able to access my other computer because I am using AnyDesk, but it says that it is not responding for some reason. But I will try to open Visual Studio. Let's see if this works. Okay, now I can access this. So, first, I'm going to show you, yes, my machine learning model, which is a console application, as you can see. This console application trains an image classification model. It will take the data from this folder. Just a second, and I will show you. Yes. There are several pictures of damage of cars. In some cases, you can see there might be a dent, right? In other cases, maybe there is a glass issue, yes, such as this one. Maybe in this case, the door has a problem, yes. So we have this information. And also we have this CSV file, which says, okay, in image one, sorry, in the first image, on image 0, we don't know what happened. In image 1, there is a headlamp issue. In image number 2, there is door scratch, and so on. So with this CSV file and the folder of images, which we specify in this program, we are going to first load the data, right? So you see here, we take this images path. Sorry, yeah, we set the images, right? Then we have an extra column which says if the picture will be for the training dataset or for the validation dataset. And as you can see, we are creating an iDataView. Sorry, no, this is a list. Then the iDataView is here. This is iDataView that I mentioned earlier. After that, we prepare a pipeline, training pipeline, right? Which is first here, right? Then in the training pipeline, we specify what is the column that we want to predict, what is the input, what is the output, what is the algorithm that we are going to use. In this case, it's multi-class because there are several categories, right? We use the image classification trainer that we mentioned earlier, if you remember. And when we use the fit method, the iEstimator is created, which means the operation is performed, okay? And after that, we have to wait. This task actually takes like 20 minutes. I'm not going to do it. But after that, I save the model. So I'm going to part from this part, okay? So this model is saved, and you can see it here. Yeah, this is the image ML model, a .zip file, which was created. So yeah, as you can see, there is some information, some change, some schema. It's this zip file, and this zip file, this model. But I can do this later. I can load the model. If you give me a second. Yeah. Let's suppose that I already trained the model. There is this method, consuming model, which loads the ML model that I created, and it can perform image classification on some other pictures. In this case, you will see that it performed this classification of these 4 pictures, car 1, car 2, and so on. These pictures are here, right? So, for instance, the first one was a bumper dent, which you can see that was the issue. For the 4th one, there is a tail lamp, which is this one. So you can see that it worked, the image classification. For this one is glass shatter, and so on. So now, what we do to put this into a mobile application? Well, we have to create a web API project, which I have here. Just a second. Unfortunately, in Xamarin applications, the ML model cannot be loaded directly. So that's why we use as intermediate step the machine learning model. So you can see here, I have my ML model in this files folder. And I have created a very basic web API, ASP.NET Core web API with just one method, which is classified under the car image controller. Basically, it will accept a picture, and this picture will be sent to the ML model. And you see in the classified image that I am loading the model. This code is the same that I had before when I loaded the model that was already trained. Yes? And after that, a prediction engine is created, and there is a result. What is happening in this picture that we supply? to help myself, I publish this ML model into Azure. And after that, I can, just a second, I will move this here. I can take it to a Xamarin mobile application, yes, which uses this service. You will see in a second. Yes, I am using my ASP.NET Core website, which was published into this URL. I think it's wrong, actually. Just a second, because I changed it. So give me a second, please. Yeah, the name is different because I was testing it here in the Android, but I think I will test it in iOS. So, sorry about this. Okay. So, yes, there it is. And after that, I will just send the picture. I sent a stream, right? And just obtain the result from this. I prepare a post HTTP request to my web API, and I will obtain a result. And this result will be displayed in the screen. Okay. So I'm just waiting for this to build. Unfortunately, well, I think we are almost out of time. But please, if you have a question, you can enter it in the chat. And while this is building, I will reply it. Because, of course, well, I want to show the application. Sorry that it is taking some time to deploy it. So, but just please, if you have a question, in the meantime, while it is deploying, maybe I can just share some resources that you can use to create this. There is .NET /ML website to learn about this framework. There are some samples. There are some documentation. And also, there is a lot of videos about ML.NET, right? And I said that this was open source. So the website, akl.ms/ml.net, is basically the GitHub, right, of this framework. So we can enhance it, we can learn, we can understand a lot of this framework. So yeah, basically that will be all for me. I'm just waiting for my ML machine learning models to be deployed. I am sorry that it is taking some time, but hopefully we will see it in a second. So please, if you have a question, just let me know, and I will do my best to answer. Or if you follow the conversation in Twitter, I will use the hashtag to show you the demonstration of this application. Okay? So please, if you have a question, thank you for your time. Thank you for attending this session. And as I said, I'm just waiting for the result. And please enjoy the rest of the event. And I hope that this session was useful for you. I will upload this code in my GitHub. ICEVEAM7. There is I here. So I will upload the code of this demo in a minute after this presentation finishes. So let me know if this is useful for you. Okay. So thank you for your comment. Yes. Yes, definitely. I upload in slideshare.net my content, so you can wait for the slides maybe in the next hour, and you will see it there. Okay. So okay. And well, I can show you something. This is the application running on Android, but for some reason it is not doing the output. But this application, basically, I just choose a picture. You can see here, for instance, this one. I classify it. In this case, it is sending the it is asking the web API to understand or to predict what is happening here. Unfortunately, as I said, well, in Android it is not working, so that's why I would like to test it on iOS, because I deploy it on the Mac, so maybe there is some issue that I would like to analyze or to check what is happening there. But yeah, I will eventually find out what is happening. So yeah, I will post it on Twitter. Okay. So sorry about this issue that happened, but I will see how to fix it. Okay. So again, thank you, and see you hopefully next time. Enjoy the rest of the event. If you have any questions, I will go to the lobby and I will be there for some time. Okay. So goodbye and thanks a lot again.